Whenever you're designing a weapon, it's important to think ahead about who will be using it. Each feature on our axe being designed for reliability and simplicity. The blade of our axe has a flat surface on the underside, and the top of the blade comes to a point. The spike on the back of the axe sticks straight out, making it easier to cast and stronger than if it were to be curved in any way.
Handles on modern axes tend to be made out of wood, but ours takes on a more traditional approach with a metal one. We took this a step further and cast the head and handle as one piece, making a monolithic cast. This eliminates an assembly process, but it also increases the strength where the head and the handle meet. The grip is bordered by rondelles and has a clear direction for holding it properly. This indexing makes it intuitive to hold correctly and to retain that orientation after a strike.
When considering alloy selection, you have to consider the use of the part itself. An axe needs toughness to take impact, but also hardness to hold its edge and withstand the stress generated by an impact force. A2 has an ideal balance of these two properties and is commonly used for applications where the part needs to retain shape and withstand wear. A2 is also air-cooled during heat treat, which simplifies the process.
So for the mold and gating design, we came up with a draining riser system. Now we did this for a couple of reasons. The gating system can be a lot of work to cut off, especially if you're using hard materials like tool steels. The second reason is that the riser can cause hot tears in your part during solidification, and if that were to happen, it would ruin our casting, so we don't want that. If you look inside, we have the axes at an incline, and we do this because we want gravity to help feed the metal down into the axe blade. This part up here is our riser. These are our gates that feed into our axe, and in the middle have our valve. We can use simulation to determine what point in time the axes are solidified and don't need any more risering, but the riser is still liquid, and at that point in time, we will open the valve and drain all of the extra metal out. Theoretically, this will give us only the axes once we do breakout.
We always make more than one mold, and our mold design makes 2 axes per mold. We made 3 of these molds just in case something goes wrong, but this should get us 6 axes. Mold design was a little complex because of the valve system, but it went together pretty easy.
The pours went well. Now we have to get started on the post-processing. Our heat treat was the standard for A2. We have a furnace on campus which made getting it done painless. A2 being an air-cooled steel makes this process very simple.